Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Go's interfaces, a fascinating aspect of the language's design. It's a truly elegant solution.
I'm eager to hear about this. From what I understand, Go's interfaces offer a unique blend of static and dynamic typing. Can you elaborate on that?
Absolutely. Go's interfaces are statically checked at compile time, catching type errors early, but they also exhibit dynamic behavior at runtime, allowing for flexible method calls. It's a powerful combination.
So how does this duck typing work in practice? I'm curious about the implementation details.
Think of it like this. If a type walks like a duck and quacks like a duck, then it's treated as a duck. Even if it's not explicitly declared as one, the compiler verifies that the necessary methods exist, and the runtime handles the actual method calls.
That's a great analogy. But how does the runtime actually manage these method calls? Is it a simple lookup table?
It's more sophisticated than a simple lookup table. Go uses what's called an interface table, or interface table. This table contains pointers to the methods that satisfy a given interface. The runtime uses this table to efficiently dispatch method calls.
So, the entitlement is computed at runtime? That sounds computationally expensive.
You're right to be concerned about performance. However, Go cleverly caches these enumerables to avoid redundant computations. The initial computation uses an efficient algorithm, achieving O(n plus m) time complexity instead of the naive O(n)m).
That's impressive. What about memory optimization? Are there any tricks to reduce memory footprint?
Absolutely. There are two main optimizations. First, if an interface has no methods, the editable is unnecessary, saving space. Second, if the data associated with the interface fits within a single machine word, it's stored directly, avoiding heap allocation.
That's clever. It seems like Go's interface mechanism strikes a good balance between type safety and runtime flexibility. But what about performance in comparison to purely dynamic languages?
That's a great question. In dynamic languages, method lookups happen at every call site. Go, however, performs the lookup when the value is assigned to the interface, moving this overhead out of tight loops. This can lead to significant performance gains, especially in parallel programs.
So the static typing aspect helps optimize the runtime performance. That's a really elegant design choice.
Precisely. It's a testament to Go's design philosophy, combining the best aspects of static and dynamic typing to achieve both safety and efficiency. The article also mentions the use of 8grams-sx.go to examine the assembly code, which provides a deeper understanding of the underlying implementation.
I'll definitely check that out. This has been a really insightful discussion. Thanks for breaking down the complexities of Go's interfaces in such a clear and engaging way.
My pleasure. And thank you for listening to Tech Bytes and News. We hope you enjoyed this deep dive into the world of Go interfaces. Join us next time for more exciting explorations in the world of technology. Goodbye.
Bye-bye.